Okay, after we get through this, we'll just start qualities. Okay. All right. Okay. Our goal today is to solve the most basic trigonometric equations. Every time I've taught this section, I've had students who have been able to figure this out, be able to work through it. I think that you'll be able to do it as well. It says find all solutions that satisfy 0 is less than theta, which is less than 360. And so here's the question. If I wrote this, 2x minus 1 is equal to negative 2. Would you know how to solve that? What would you do? Add 1 and divide by 2. And that value for x would be what satisfies the equation. The question for us is what value for theta satisfies the equation? Is it 20 degrees? Is it 40 degrees? Is it 190 degrees? What value satisfies that? And so we will start just like you would with this problem. We add 1. So I get 2 times the sine of theta is equal to negative 1. Now, you guys right now, you like it, don't you? You just add 1 to both sides. Now we divide by. So the sine of theta is equal to negative 1/2. This is the new part. We have to figure out an angle. Do you remember what you do with your calculator when you want to find an angle? You do the inverse. But please pause. Okay, please pause. Before we inverse, it says that the sine is negative. And here's where we're going to use what we learned about reference angles yesterday. First of all, in which quadrants is sine negative? Remember, all students take calculus. In 3 and 4. So what I will do is if sine is negative, I will draw a reference angle in 3 and a reference angle in 4. Remember, the reference angle is the angle formed between the terminal side and the x-axis. Okay? Once I make that one drawing, the rest is pretty easy to figure out. Take your calculator, turn it on. No. It's what my kid's bedroom looks like. First of all, because 0 is less or equal to theta, which is less than, say, 2 pi, that would mean we were working in radians. We're not going to have you solve in radians. We're going to have you solve in degrees. So therefore, my calculator should be in degrees. The second thing that we do is we type in sine inverse. Again, we're trying to find an angle. So we don't take the sine of negative 1/2. We go second sine, so sine inverse. Now here's where you guys need to be very careful. You don't plug in negative 1/2. You know where it's negative, the third and the fourth quadrant. So we just type in 1/2. And we get 30. 30 is not our answer. 30 is the reference angle. So remember yesterday when we calculated reference angles? We did it so that we could solve equations. These are the 2 spots that I want to identify. If this reference angle is 30, then what would this entire angle be? What is this location right here? How many degrees is right here? 180. So I'm 30 past 180, which is, so theta is equal to 210. What spot is right here? So I'm 30 back of 360, which is, Not too bad, huh? So when we practice, we're going to do 6 examples here. You'll get pretty good at it. We're going to jump to number 3, then we'll go back to 2. What do you think I do first here? Minus 5, negative 6 tangent of theta is equal to negative 8. Now, divide by negative 6. Tangent of theta equal to 4 over 3. Now I have to set up my quadrants. I have to decide where is tangent positive. Again, if you don't know how to do this, you have to remember the saying, all students take calculus. So therefore, they are all positive in the first, so I have a reference angle there. And tangent is also positive in the third, so I have a reference angle there. Is the angle formed between the terminal side and the y-axis, or the terminal side and the x-axis? So I always draw the angle with the x-axis. So it looks like 2 spots. One's between 0 and 90, the other is between 180 and 270. How do I figure it out? I determine the reference angle. Go to my calculator. What do I press? Second tan, and then 4 divided by 3. We get 53.13. So yesterday, again, we practiced reference angles. Now we want to find where those reference angles come from. What's this one going to be? 53.13. How do I figure out this one? Add to 180. What do you think? Does it seem like something we could do? Okay. We're going to go back to 2. What might make problem 2 more difficult? Secant. But it's really not that big of a deal as long as you can just remember one piece. If you flip secant, what do you get? Cosine. So we'll solve it just like normal. Plus 13, negative 5 secant theta equal to 11. Divided by negative 5. Secant theta is equal to negative 11 over 5. Do you have a secant button on your calculator? What button do we have? Cosine. So I can't write it as secant. I have to write it as cosine. Well, if I switch that to cosine, what do I do to the other side? Flip it upside down, negative 5 over 11. Now I can make my quadrants and solve. All students take calculus. So it looks like cosine is negative. In which quadrants is cosine positive? 1 and 4. So it's negative in 2 and 3. So I draw 2 reference angles. I want to figure out whatever that angle is. How do I do that on my calculator? Cosine inverse, 5 over 11. And I get 62.96. So how do I get my angle up in the second quadrant? What do I do? 180 minus 62.96. Get 117.04. And then we'll take 180 plus 62.96, 242. Not bad, huh? Yeah. Excellent question. Sine is negative. Tangent is positive. Cosine is negative. Whatever sign you come up with, that will tell you where you make your reference angles. Is that better? Okay, good question. 3 more examples. Oh, 4 looks so confusing, doesn't it? Really not that bad. What do we do first? Distribute -6 cotangent of theta plus 4 plus 3 equals 6 minus 2 cotangent of theta. Whoops, sorry. Plus 3 plus 3. So we get -1. -6. All right. And then when I do a 6 minus 1, I get 5. So 5 minus 2 cotangent of theta. What should I do at this point? Now I've combined some terms I've distributed. I'm going to get my cotangents on one side. I'll add 2 cotangent of theta to both sides. I know that we've not done that operation before, but what do you think -6 cotangent of theta plus 2 cotangent of theta is? -4 cotangent of theta plus 6 is 5. Then what? I'm going to subtract the 6 after my smartboard stops being stupid. Okay. -6, -4 cotangent of theta is equal to -1. Divide by -4, cotangent of theta is equal to 1 over 4. Oh no! I don't have a cotangent button on my calculator. What should I do? Change it to tangent. Tangent is equal to 4. So, to Colleen's question, why look for where a tangent is positive or a tangent is negative? Positive, because it says positive 4. In which quadrants is tangent positive? The first and the third. So what I need is I need those reference angles. How do I find the reference angle? Tangent inverse on my calculator. What happened to mine? What did I do wrong? It didn't, when I pressed the board, I didn't get the tangent inverse, so 7596. So what's one of the angles? 75.96. The other angle, what would I do? Add to 180 because it's past 180. 255.96 degrees. Two more examples. Subtract the 1. 4 cosecant of theta is equal to -7. Okay, I got cosecant of theta is negative 7/4. What does that mean? What should I do now? Sine of theta is negative 4/7. So is sine positive or is sine negative? In which quadrants is sine negative? 3 and 4. All students take calculus. So all are positive there. Sine's positive here. So sine's positive in the first two. Therefore, it would be negative in the other two. Giselle? No? Okay. So what do I punch in the calculator? Second sine inverse. But do I type in negative 4/7 or positive 4/7? Always type in the positive. We've already determined the where the negative applies. Negative means that it's in the third and fourth quadrant. So we just have to do 4 divided by 7. We get right around 30 degrees, 34.85. Smartboard's acting up again. It's having a rough time. So I will add 180 and I get 214.85. And then I subtract from 360 and I get 325.15. Ready for the last example? By the way, your worksheets that you had the past couple days, I made answer keys for both of them, and they are posted. Okay, last example. What do I do first? I will distribute 2 cosine of x minus what? 6 plus 1 is equal to 4 minus 6 cosine of x minus 2. Distribute the negative all the way through. Good. So I have 2 cosine of x, negative 6 and positive 1, and then negative 6 cosine of x, 4 minus 2. Add the 6 cosine over to the other side, and I get 8 cosine of x minus 5 is 2. Add the 5. 8 cosine of x is equal to 7. Divide by 8. Okay. Everybody pause. Suppose instead of 7/8, suppose I came up with 8/7. I want you to think of something real quick. When we graph sine and cosine, what was the highest value that sine or cosine could be? What was the smallest it could be? So if you get cosine of x is 8/7, is 8/7 outside of the bounds between 1 and negative 1? So that would be a no solution. But is 7/8 less than 1 and greater than negative 1? Yes, so there is a solution. All we need to do is identify where cosine is positive. Which quadrants is cosine positive? 1 and 4. Do I have to flip it? Nope, because I have a cosine button on my calculator. Cosine inverse of 7 divided by 8. And I get 28.96. So theta, or x in this situation, looks like it's an x, is equal to 28.96. I subtract the other from 360. I get 331.04. And that's that. So not too bad, huh? I mean, I know that some of the trig we do is challenging, but I think that this is a very, very good piece that you can accomplish. Now, yes, we're going to add some, as you look further along here, yeah, we're gonna add some squareds into it. We're going to change things a little bit, but you know, we can handle this, okay? So your assignment is the worksheet that I'll hand out to you, and I want you guys to know that when we get back from break, the first thing we'll do is we'll review this, because A, there's a number of people not here today, and B, you'll need a reminder, won't you? Okay. All right.